Today we'll be looking at the most used piece of equipment in a forensics lab, and that is the microscope. We'll be learning about the different parts of it and what they do and how it all works. So let's get to it. The type of microscope we'll be using in the lab is what's called a compound light microscope. And there are several parts to this, each having a specific function and purpose. Let's look at each part of the microscope and its use. A compound light microscope uses two lenses. Light passes through a sample, which creates an image. The image is passed through an objective lens first, then an eyepiece before reaching your eye. The two lenses work together to magnify the image so that it appears larger to your eye. The eyepiece, also known as the ocular lens, is where you will view the specimen. That's where you put your eye. The microscope body tube separates the objective and the eyepiece and assures continuous alignment of the optics. The revolving nose piece rotates to change between different objective lenses. You should always change the objective lens by turning the revolving nose piece, not by pushing or pulling on an objective lens. That can actually break the lens. There are usually 3 or 4 different lens choices, ranging from magnification of 4 times to 40 times. If there are 4, the 4th one will magnify 100 times. The low power objective lens is the shortest one and it magnifies 4 times. The medium power objective lens is the middle-sized one and it magnifies 10 times. And the high power lens is the longest one and it magnifies 40 times. And that one will be the closest to the specimen when you're looking at it. Sometimes you'll have 100 times lens, and ours have that. It's also called an immersion lens. What an immersion lens does is it will use an immersion oil that directs more light through the objective and gives us a clearer image. We will not use these. Nothing that we're looking at is going to need that high of a magnification. The stage holds the slide and it has a window that allows light to pass through the specimen, and the stage can move up and down for what we call macro focusing, that is large scale focusing. The diaphragm down here turns to adjust the amount of light that passes through the specimen. You can turn the diaphragm to change the amount of light, basically to give you the best quality image given the equipment that you're using. The arm allows the user to hold the microscope securely, and the base supports the microscope. When you're carrying a microscope, you should always use 2 hands, one on the arm and one on the base. The stage clips hold a slide in place on the stage for viewing. The light source shines upward through the specimen and to the lenses. The coarse adjustment knob should be used first. It moves the stage up and down to get the specimen so you can at least see it. This knob should only be used with the low and medium power objective lenses. The fine adjustment knob fine-tunes the focus after using the coarse adjustment knob to bring the specimen mostly into focus. And this fine adjustment knob can be used with all of the objective lenses. Let's practice calculating the total magnification that you'll get with each lens. To get this number, you will multiply the magnification of the objective lens by the magnification of the eyepiece. Pretty easy. If we're using the low power objective lens right here, we would say 4 times 10 gives us a total magnification of 40 times. With the medium power, it's 10 times 10, so we have 100. And with the high power, we have 40 times 10 or 400 times. Let's review some rules for using microscopes. Number 1, always carry the microscope by the arm and the base. Number 2, always start viewing a specimen on the lowest power and with the stage all the way down. Number 3, adjust the diaphragm to ensure light is passing through the specimen. Number 4, if you need to clean the lens, you need to use lens paper only. If you try to use anything else, it can scratch the lens. Number 5, return the objective lens to low power when you're finished viewing something, or in between viewing different specimens. You always want to go back to low power. And number 6, ensure that slides are removed from the microscope and the cord is wrapped around the microscope when you are done. Number 7, always place a dust cover over the microscope when you're done with it. This protects it and keeps dust from getting in the microscope. Number 8, always lower the stage before putting the microscope away. Number 9, keep the microscope clean. Keep it covered when you're not using it. That's kind of what we've talked about already. Number 10, do not use the coarse adjustment knob with the high power objective lens. This could break your slide because it will be too close to the slide, and if you're trying to do macro focusing or large scale focusing, you could bring that slide too close to the lens and it would break it and possibly break the lens. Number 11, don't put specimens directly on the microscope stage itself. You're always going to use a microscope slide to put it on. And number 12, don't touch the lenses with your hands or anything else. If you touch them with your hands, you could get fingerprints on them that will interfere with you being able to see your specimen. Lastly, treat your microscope like it's fragile, because it is fragile. The last thing we're going to go over is how to make what's called a wet mount slide. This is how you will mount most things that you will be looking at under the microscope. First thing you'll do is place a drop of fluid, usually water, in the middle of the slide. Then you will use tweezers to position the specimen in the drop of the fluid. Then take the cover slip, that's the little square thing, and place one side of the cover slip at an angle so that its edge touches the slide and the outer edge of the drop. In this picture, they have it too far away from the drop. You want that edge that's touching the slide to be right on the edge of the drop of water. Slowly lower the cover slip down, avoiding air bubbles as much as possible. Most problems with air bubbles come from not applying the cover slip at an angle or not touching that liquid drop when you first put it down at an angle, or from using a liquid that is just too thick. If the liquid drop is too large, the cover slip will float on the slide, and that will make it hard to focus on the subject using the microscope. So you want to make sure your little drop of water isn't too big. But that's how you make a wet mount slide.